purpose of today's lab is to find a relationship between horizontal position and time and vertical position and time for a projectile. So in other words, what we're going to do essentially is throw up a baseball, a soft baseball, a T-ball, through the air. We're going to measure the horizontal position and the vertical position and the time as that baseball goes through the air, and we're going to plot two graphs, horizontal position versus time, vertical position versus time, and identify what the relationships between those variables are. So our problem, written in the form of a question, as we always do, is what is the relationship between horizontal position and time and vertical position and time for a projectile? Now, what are the materials going to look like? Yeah, they're pretty simple, actually. I'll tell you what, though, I'm not going to list them. I'm going to tell you essentially what you're going to do in this, and then you're going to write down yourself what the actual materials are, and then you're going to phrase a procedure in your own words. It boils down to this. You're going to take a ball, and you're going to throw that ball lightly so that it follows a parabolic path. You're not going to huck it as hard as you can. If you're a baseball player, hey, that's great. I don't want to see an 85-mile-an-hour fastball in the atrium. I want to see just a nice soft toss underhand in the atrium. Now, how are we going to measure the position and time, horizontal position, vertical position, and time of that baseball? You're going to video the ball moving through the air. Now, it's important to note here that your camera or your phone, normally as you're holding it in your hand, is going to shake a little bit, right? You need to find a way to brace that. You need to find a way to keep that phone from shaking around a little bit. The computer is not going to be able to distinguish between the motion of the baseball and the motion of the thing that's recording the motion of the baseball. So things are going to be off. Your data is going to be off if you don't have the phone held still. You're going to figure out a way to do that. So you're going to throw the baseball, you're going to record the motion of the baseball, making sure that you get either all or most of the path of the baseball in the frame of the video. If you skip a little bit at the end and at the beginning, that's okay, we can live with that, but you're going to get all or most of it in the video. Now, what's also important to note here is that we need to have a meter stick included there. So somebody's going to throw a ball like this. Somebody's going to stand underneath, directly underneath the arc of the baseball, not in front of it, not behind it, directly underneath the arc of the baseball with a meter stick in their hands. Don't hold the ends of the meter stick, because then the camera is not going to be able to distinguish exactly where the ends are. Hold it like this so that we can see clearly when we're going to analyze the video where the ends of the meter stick are. The reason that we have a meter stick in there is because the computer program that we're going to use to analyze this motion doesn't understand what a meter is. It knows what a second is because it knows the frame rate of your phone is 30 frames per second. So it can find the time fairly easily, but it doesn't know what a meter is. We have to tell it what a meter is so that we can measure the distance, or the position, I should say, that way. Make sense? Don't forget that meter stick. That's critical. And again, make sure that if the ball is being thrown on this plane right here, don't have the meter stick up here, because the scale won't be correct, right? We need to be right along the same plane as the baseball is moving, so that we have the same scale, 1 meter, whatever. Make sense? Once you've collected that data, my suggestion for you is either one of the following two options here. Either upload that video to your Google Drive if you have the Google Drive app installed on your phone, or the second option, if you have an iPhone, I have a cord for the iPhone on my desk. So what you can do is literally just come back, log onto a computer, plug in your phone, and literally treat your phone as a USB drive and drag over that video onto the desktop of your computer. And that will be quicker, definitely quicker than emailing it to yourself. Make sense? If you got an Android, I think I have a charger that'll work with that as well, or a charging cord that'll work with that as well. I know I have one that works with an iPhone. Bottom line is, you got to get that video to a computer, not to all members of your group, but you need to get it to a single laptop computer. And then you're going to analyze it, and I'll tell you a couple of things about analyzing it in a few minutes. What's your data table going to look like in the end? It's going to look like this. It's much simpler than the data table that we had for, or that we initially saw at least, for our for our constant velocity and for our acceleration labs. Those had like 10 or 12 different columns. This is going to produce 3 columns, the 3 columns that we want: time, horizontal position, and vertical position. Now, we got to plot two graphs. The first graph is going to be horizontal position versus time, and the second graph is going to be vertical position versus time. In order to do that, I would suggest in your spreadsheet, now you don't need to write it down this way in your lab write-up, but in your spreadsheet, I would suggest creating two tables. The first table would be time and horizontal position, and the second table would be time and vertical position. We know from previous experience that it's easier to plot graphs if we have a two-column table, right? This is probably the one that you would include in your write-up, but you can separate it for purposes of making the graphing easier. Now, I'm not going to tell you what shapes you're going to get here, although you could probably predict pretty easily what shapes you're going to get. But I will tell you this. If you get something that looks like this or like this, pretty close to one of those two, then draw your trend line, select the option linear. If you get something that looks like this or like this, select polynomial. In Physics 20 and Physics 30, every relationship that you see is going to be either linear or polynomial. So you can plot the trend line pretty easily by selecting one of those two, and it's usually pretty obvious whether it's linear or polynomial. There's another option there, and sometimes it's a little bit hard to distinguish between polynomial, but I'll tell you the other option is not what you have to pick. So it's either linear or polynomial. You'll figure it out when you see what the graphs look like. Your conclusion is quite simply, what are those two relationships? What's the relationship between horizontal position and time? The relationship between horizontal position and time is acceleration. We know this because the horizontal position versus time graph produced a line that curved upwards, or whatever it happens to be, right? Whatever that relationship happens to be, make sure you specifically reference the graph. Don't just say, oh, it's constant velocity because of the graph. It's constant velocity because the graph was a straight line. Not just the graph was a straight line, but this particular graph was a straight line, or was curving upwards, or curving downwards, or whatever. And finally, we got our sources of error, of course. We want to have 2 or 3 good sources of error and suggestions for improvement. Don't sweat it. Hey, listen, if you figure out something to fix something or a way to make something better, that's great. Do it. Don't skip that just so you can have a source of error. Do it, and then include that in your source of error. It's okay. There was a couple groups in the last class. They come up with I thought, a really, really neat way of making sure their phone was braced and wasn't going to budge at all. They can address that in their sources of error, right? There was a potential issue of keeping the phone steady. Okay? This is what we did to keep the phone steady. This is what we did outside of the procedure that was given to us to make sure the phone was kept steady. So things like that are okay. I would rather you fix something. I would rather you do something well the first time than just save the solution for a source of error.